बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम स्टूडेंट्स। सेकेंड ईयर मैथमेटिक्स का जो सीरीज़ चल रही है, आज हम सेकेंड ईयर के चैप्टर नंबर 1 की जो डेफिनेशंस थी उसका लास्ट लेक्चर है। इसके बाद प्रॉपर एक्सरसाइज पे आ जाएंगे हम। और ये जो सारी डेफिनेशंस मैंने आपको बताई हैं पिछले तमाम लिंक्स के अंदर, पिछली तमाम वीडियोस के अंदर, ये सारी की सारी एग्जामिनेशन पॉइंट ऑफ व्यू से बहुत ज़्यादा इम्पॉर्टेंट है। इस लिहाज से इम्पॉर्टेंट हैं ये डेफिनेशंस आती हैं, और कॉन्सेप्ट के लिहाज से आप जब एक्सरसाइज स्टार्ट करेंगे, अगर आप इन डेफिनेशंस को के लेक्चर सुन के एक्सरसाइज को स्टार्ट करेंगे तो आपके लिए बहुत ज़्यादा आसानी हो जाएगी। ये जो टॉपिक चल रहा था ये था फंक्शंस की जो टाइप्स के ऊपर है। अब फंक्शंस की काफ़ी टाइप्स मैं आपसे डिस्कस कर चुका हूँ, ये लास्ट लेक्चर है आज फंक्शंस की टाइप्स के ऊपर। उसके बाद फिर हमारा जो अगला लेक्चर होगा वो डायरेक्ट 1.1 एक्सरसाइज पे होगा, और वो सारे के सारे जो क्वेश्चंस हैं और उनके जो आंसर हैं वो यहाँ पे मैं करवाऊँगा भी, और साथ उसकी जो कॉपी है वो आपको अपलोड हुई मिल जाया करेगी। ओके, तो आइए अब हम बात करते हैं लास्ट लेक्चर के अंदर जो हमने कल की वीडियो में देखा वो था ट्रिग्नोमेट्रिक फंक्शंस। आज हम देखेंगे हाइपरबॉलिक फंक्शंस क्या होते हैं। If you remember, there are 6 trigonometric functions such as sine, cos, tangent, secant, cosecant and cotangent. Before starting the video in detail, you are requested to subscribe the channel and share it with those students who have not prepared yet for the second year mathematics if they want to get certain marks. ओके, सो टॉपिक की तरफ वापस आते हैं। हाइपरबॉलिक फंक्शंस, सच फंक्शंस आर एक्चुअली डिफाइंड बाय फॉलोइंग इक्वेशंस। sin hx is equal to ex minus e raised to power minus x2. This is actually the sine hyperbolic function, and in similar way there are cos hyperbolic function, tangent hyperbolic function e power, similarly cotangent hyperbolic, reverse of tangent, secant, it will be the reciprocal of cosine, 2 over ex plus e minus x, and cosecant hyperbolic, it will be the reciprocal of sine hyperbolic, ex minus e minus x. So these are the hyperbolic functions, and they are frequently used in integration, differentiation and limits. Why we are calling it hyperbolic, and why they are expressed in terms of sine, cos and tangent, this is not our area of discussion. Or the simplest answer why they are expressed in terms of sine, cos and tangent, the simplest answer for at this stage, you can simply say, if you trace the sine graph, first of all I'm talking about simple trigonometric functions. If you trace the sine or cosine graph, you actually get a curve. The curve, like you get actually a circle. For example, if you trace, this is a sine. If you trace this curve, you actually get this circle. This is the graph for the sine and the cosine function. And similarly, when you trace the hyperbolic function, you actually get the hyperbola. Hyperbola, parabola and ellipse, these are different sections of a cone. If you cut the cone and you have from certain angle, you actually get 3 different kinds of the shapes which we study in detail in chapter number 6. Very much important chapter. Parabola, hyperbola and ellipse. if you trace the hyperbolic function of a sine, you actually get a hyperbola. Just like if you trace the simple sine function, you get the circle. So that's what you need to remember. That's why they are expressed in terms of sine hyperbolic, cos hyperbolic, tangent hyperbolic, cotangent, secant and cosecant. All you need to remember their formulas. What I have told you, there's no need to remember at this level. Just you need to memorize their formulas. Just like there are 6 trigonometric functions and corresponding their inverse trigonometric functions. Also there are 6 inverse hyperbolic functions and they are expressed in terms of natural log. That's not a part of syllabus, so they would be discussed at higher level mathematics in BSc or at engineering level. Now the important one, yes, hyperbolic functions, simple hyperbolic functions are of great importance. That's what you need to memorize their formulas. Okay, explicit function. This is very much of great concern. Explicit function. If y is what? Dependent variable. Can be expressed in terms of x, which is independent, then such function is called explicit function. Mean to say that if you look at the definition of this function, if y which is actually a dependent variable, the general notation for the function is y equal to f of x. Means all expressions containing y are on one side and all those expressions in which contains x are on the other side of the equation. Such functions are called explicit functions. It means y and x can be separated easily. For example, y is equal to x squared plus 5x plus 3. This would be an explicit function. Similarly, xy minus x square y is equal to 2x plus 5. You can easily say it over here, y and x are mixed with each other, but you can easily separate y. 2x plus 5. Y 2x plus 5, x minus x square. So this would be an explicit function. It means you can express y completely in terms of x. Such functions will be termed as explicit function. There is inverse of that function, implicit function, reverse of that function, implicit. It means you cannot express, cannot implicit. If y, which is a dependent variable, cannot be expressed in terms of x, then such function is called an implicit function. It means x and y are joined together and you cannot make them separate. Just like x square y minus x y square is equal to 5 x plus y. So this is actually the example. If I take x from common here, if I take common x square minus x minus 1, y is equal to 5x divided by x square minus xy minus 1. You can easily see y and x are exactly living together in this expression. You cannot make them separate. So such expression in which y cannot be completely expressed in terms of x, such functions are termed as implicit functions. I would like to repeat it again. Such functions in which y, which is a dependent variable, cannot be expressed in terms of x, which is an independent variable, is termed as an implicit function. Very much important with respect to examination point of view, short questions. Multiple times these definitions are being asked in examinations. Okay, now these are another two important functions. Before going into the detail of even and odd function, let's we talk about the parametric functions. Parametric functions. Normally, all of you are well familiar if you have an idea of the basic idea of the function. In function is such a machine which takes input, process it, and give you an output. There is only one independent variable and corresponding one dependent variable. Corresponding to one input, you will have one output. But sometime it's usually happen uh, more than one variables, more than one dependent variables are depending upon a single independent variable. I am repeating these lines again. Sometime it's happen two or more than two dependent variables are actually depending upon a single independent variable. Such functions are termed as parametric functions. For example, x is equal to at square, y is equal to at cube, where a and b are constants. X is also depending upon t and y is also depending upon t. Uh, Basically, you can easily have an idea both x and y are independent with respect to t. If you put the value of t, you will get the value of x, and if you put the value of t over here, you will get the value of y. Both x and y are depending upon a single variable t. Such functions in which two or more than two variables are depending upon a single variable are termed as parametric functions. For example, x is equal to a cos of theta, y is equal to b sine of theta. X also depend upon theta, y also depend upon theta. Such are also the examples of parametric function. And the one thing very much important from examination point of view, from anti-test point of view, objective type, this common variable is called parameter. This common variable is called parameter. So such functions are called parametric functions. And this is not perimeter. Perimeter is something else. Perimeter is actually related to the total length of the total boundary. This is the parameter, the common variable upon which the two or more dependent variable depend upon a single variable. That parameter is called that variable is called parameter. And to solve such functions, you actually need to eradicate this parameter first. How? We will see it in 1.1 exercise. Now, finally, we reach the final two definitions, the last two definitions, even function and the odd function. Even function. What are even function? The function which define if f of minus x is equal to f of x, then such function is called an even function. Actually, you replace x with minus x and you get exactly the same function. Minus no longer play an important role in changing the function, in changing the nature of function, and the original function is actually reproduces, then such function is called an even function. How? For example, if I say f of x is equal to x square, you replace x with minus x. F of x minus x is equal to square of a negative number is always positive, and original number has been reproduced with positive sign, so such function is called an even function. In trigonometry, you can have an example of cos of theta. If we replace x with minus x, cos minus, from if you have learned first year trigonometry 6 chapters in detail, you must be familiar. Cos actually absorbs the minus sign. How it's happened, it's a long discussion, long detail. So this is also an even function. Now, multiple example you will study in an exercise 1.1. So all you need to remember, if you replace x with minus x and the original function is reproduced, then such function is called an even function. Odd function. If f of minus x is equal to minus f of x, mean to say that you actually replaces the function with negative independent variable, and the original function is reproduced with the negative sign, then such function is called an odd function. For example, f of x is equal to x cube. If you replace x with minus, and cube of the negative number is always negative, original number reproduced along with the negative sign. So such functions are called odd functions. In trigonometry, you can have an example of sine function, which is an odd function. X replaces to minus x, sine minus x, minus sine x, and you know sine actually does its nature of sine does not change, gets changed if you put the minus sign, if you replace the x with the minus x. So minus actually comes out from the sine function, and function original function is reproduced along with the negative sign, then such function is termed as an odd function. So this was all about definitions of the function that come to an end. Now in the next lecture, in next video, you will study exercise 1.1, और तमाम बच्चे जो कि पेपर देने जा रहे हैं उनसे गुजारिश है कि वो सेकेंड ईयर जिन्होंने कुछ नहीं किया वो इन वीडियोस को देखें, और आपको ये जो एक्सरसाइजेस हैं ये मिलना शुरू हो जाएंगी। आप लिंक नीचे देखें तो वो डाउनलोड कर सकते हैं, वहाँ से आप वीडियो को लाइक करें, सब्सक्राइब करें और इसको शेयर करें। थैंक यू, अल्लाह हाफ़िज़।